So we've been talking about the elements, and we also talk about how we arrange these elements in the periodic table so that we can see patterns. And we talk about several patterns that we see within the periodic table. But you see, we also talked about the fact that many of these atoms would like to combine with other atoms in order to maintain an electrically stable cloud. And we'll talk more about this in this piece of the video lecture series. So in comes the idea of atomic combinations, that atoms will actually rarely ever show up by themselves, but they will normally show up in combinations, which we call compounds or mixtures or things like that. And so before we start, let's talk about mixtures. Now, mixtures are not actual chemical combinations. They're just basically getting two substances and putting them together without actually chemically combining the substances into new substances. So when you do a mixture, you're actually doing a physical change. You're not changing the chemical composition of the matter. Like, for example, when you put salt into water, it's still salt, it's still water, it's just both in the same place. You didn't chemically change the salt or the water. Now, there are two major kinds of mixtures. One is going to be homogeneous and the other is going to be heterogeneous. Now, homogeneous mixtures look like that picture there. Everywhere you look at the pictures, you have an equal distribution of the material, like you see over there, or like you see in this cup over here. All right. Now, a heterogeneous mixture is going to have an uneven distribution. Look how we have more yellow on this side and more green on this side, right? And you see the same kind of pattern happening here or here. Of course, you have layers. So I hope you understand the basic difference. Now, remember, homo means the same, like, and hetero means different, and that's why it's easy to remember. Homo is the same everywhere. Hetero is going to be different in different areas of the mixture. Now, how much you think it's homogeneous or heterogeneous may depend on how closely you look at it. And the best example of that is blood. When you see someone bleeding, all you see is this red muck, and you think that's a homogeneous mixture. Everywhere you look, it's going to be the same. Well, not really. If you allow the blood to sit out, it will actually separate into three basic parts. It will separate into red blood cells, white blood cells and platelets, and the plasma. There are different parts to blood. And if you actually look at blood, you'll see that some areas will have more white blood cells than others, some areas will have more red blood cells than others, some areas will have more platelets than others, and so it's really a heterogeneous mixture. So this is a good example that shows you that the kind of mixture that you think it is may depend on how closely you analyze that mixture. Okay? Now, in terms of solutions, these are going to be the most common types of homogeneous mixtures. Solutions is any time you get a material that's completely equally distributed throughout the medium, but at the same time, it's a solution because once something is dissolving something else, something is acting like a solvent, something is acting like a solute. What does that mean? The solvent is a material that will surround the solute on all sides and basically separate the pieces of the solute. So for example, look at here, the best example is salt. You get the molecules of salt and it looks like a crystal like this. But when you put it in water, the molecules of water will surround each of the parts of the salt to the point that you won't be able to see the salt anymore as it dissolves into the water up there. And that is the definition of a solution. When water, the solvent, surrounds the salt, which is the solute. So solvent is what does the solution, and the solute is what's dissolved into the solvent. When you talk about solutions, in comes the idea of solubility and concentration. Now, solubility is how much salt or how much of whatever solute you can try to put in the solvent. Now, that's going to depend on a lot of things, For example, the hotter the solvent is, the more spread it's going to be, the faster the molecules are moving, the easier it's going to be to dissolve things in it, and the more things can actually fit in it. It's also going to be easier to dissolve things if you stir things, and it's also going to be easier to dissolve things if they're tinier, because it's easier for the water to surround them, okay? And also, it's going to be easier to dissolve if you have more solvent, and it's also going to depend on the kind of solute and the kind of solvent that you're actually using. Now, the concentration is different. It's not how much you can dissolve, but how much is dissolved in a solution. And then you have the ideas of saturated, unsaturated, or supersaturated. A saturated solution has as much in it as it can possibly fit in it. An unsaturated solution has less in it that can possibly fit in it. And a supersaturated solution somehow has more in it that can possibly fit in it. And you do that by first you're warming it up, which allows you to put more stuff inside. Then you let it cool down, and it stays in solution. Then you drop one more drop of salt, the whole thing falls off. It's pretty cool to do. And these are some of the cool concepts that we review when you do biology again. And there's a video lecture series just about this. Okay? Now, for now, you'll just have to get these general concepts in your mind. Okay? Especially the idea of what a solution is, which is basically whenever you get a solvent surrounding a solid, it's going to be homogeneous everywhere. Everywhere you look at the solution, it's going to be the same. See, you here see another solution forming. As you stir it, it's going to become homogeneous. You see the same process happening on the top like there. And salt water is another good example. But remember, solutions don't have to be liquid. They can be gaseous solutions. Look at here. A gas is a mixture of two gases put together. So natural gas plus a gas that causes it to smell like something. Also, things like alloys, when you combine two metals together in a way that's indistinguishable from each other. Like you put carbon and iron together to make things like steel. Or in the same thing, bronze, which is a mixture of two metals. So you see how these solutions can also be solid in alloys or gaseous. All right? And even though people don't realize that those are actually solutions. Also, one more thing, in terms of liquid solutions, remember that polar molecules will tend to dissolve in polar molecules, and non-polar molecules will tend to dissolve in non-polar molecules. If you put something polar and something non-polar, they probably won't mix together and form a solution, and that's why you get that oil separated from water, because oil is non-polar and water is polar. And we're going to explain what that means in a second when we talk about chemical reactions and types of bonding. All right? So that's basically solutions. Now, you also have suspensions, colloids, or emulsions. Now, these concepts are actually used interchangeably most of the time, but basically suspensions, colloids, emulsions are basically things that may look like a solution, but they're not quite solutions. For example, look at this milk here. It actually looks like it's a solution. It looks like the same everywhere, but if you let it alone, it will sit out and separate into layers. Have you ever done that? Notice that the milk had stuff in the bottom and then liquid on the top? Same thing about ketchup or vinaigrette or something like a dust storm or oil and water or something or paint or things like that. So suspensions, colloids, emulsions are things which look like solutions at face value, but if you look at it closely, you actually realize it's not really a solution. Okay? Now, suspension is like the general category, okay? So anything like that is going to be a suspension, and the best example I can think of is like the particles of the dust storm, which are suspended into the air. They're not really dissolved in the air, they're like suspended in the air. Dust in the air is an example of suspension. Now, a colloid is a specific type of suspension that wherever you look at the liquid, it looks like it's homogeneously distributed. But it's not really dissolved because there's no solvent surrounding the particles and the way it is in a solution. It's just everywhere about the same, but it's not really dissolved. And an emulsion is actually a mixture of two things that shouldn't mix, but they're mixed together, even if only temporarily, like you get in vinaigrette or milk or ketchup or mud or things like that. Or it's even possible to, if you heat it up enough, to temporarily mix oil and water. But eventually they will separate from each other, and that's what an emulsion looks like. All right? Now, these are physical distinctions about matter.